Yeah, so today I'm going to go over one of the challenges from last night. I think I threw a poll up in the November Platoon chat or November chat, and it seemed like Roman numerals was the winner for that challenge. Yeah, so I'm going to go through the process. Again, I know we've done this a few times, but just go through the entire process of forking from GitHub and then cloning it down to my local machine and then starting a project that way. And then we'll kind of tackle the coding challenge together. Hopefully a lot of you guys were able to complete it. If you guys got stuck, that's not an issue. Obviously, we just want you guys to attempt it and try to solve the problem to your best of your abilities. Hopefully pair programming yesterday went well for you guys. We'd love to hear your thoughts later on in the day about that. But yeah, so after we do one of the coding challenges from last night, I'm gonna give you some additional JavaScript fundamentals, just to go over some data structures and a few more items on JavaScript. But the main focus of the lecture will be introduction to Python. So I know some of you guys may have worked with Python before. Others you might be kind of scared about, like, oh no, do I have to learn a totally different language? Don't worry. If you know JavaScript or any language, it's kind of easy to pick up a new language, especially Python. It's definitely on the easier side as you go with it. So yeah, we're going to just talk about Python fundamentals, kind of just introduce you to the syntax, just run a simple application, and kind of go through the motions there. All right, so that's the agenda for today. So to start, I'm going to do the Roman numerals challenge from last night. So I'm going to go through that process. So let me share my screen here. Share that. Can everyone see my screen? Yes? All right, cool. All right, so I've got my curriculum up here. As always, the assignments for the day are at the bottom. So I'm going to go to yesterday's curriculum. So we have our 4 challenges in Git practice. If you guys were able to do that, that'd be great. Again, Git, I just kind of treat it as I learn it. I learn it as I go, as I need to learn new features. I'm not an expert. I don't have everything memorized about Git. But let's go to Roman numerals. So I click on that. And it'll take me to the GitHub page for November Platoon. So always remember, you got to fork first. If you don't fork, you could still download the challenge, but you won't be able to upload it. The reason being is we don't give you guys write permissions to our main repository. So I'm going to fork it right now. So I'm going to choose my personal repository, click that, and it's going to take a few seconds. The wheels are spinning there, and should fork over shortly. All right, great. So now if I look at the top, it's in my personal repository, encore-cp. Now that I have it forked over, I'm going to hit the code button. And then here's the URL that I need to copy. So I can hit this clipboard button, and that should copy it for me. And now I could download it to my machine. So if I bring up my terminal, let me clear this window. Make that a little bigger. All right, so I'm going to navigate to where I want to put this. All right, so I have a challenges folder, so that's where I keep all my challenges. So I'm just going to do git clone, and actually, let me back up. Let me just list my items in this directory, and I got to type that correctly. All right, so I have a few folders in here already. I have 99 bottles, def grandma, factorial in here. But if I do git clone and then paste the URL that I copied before from GitHub, it's going to do a few items, cloning, completed, great. So if I hit ls now, I can see that it added a Roman numerals directory for me. And now I can cd into that. So I just type ro, hit tab, which is a shortcut to autofill. And now in my directory, if you notice, my prompt says master, which tells me it's a git managed folder. And then I'll just hit code, period, and that should open a VS Code window for me, hopefully. All right, we got that going. All right, so this is my Roman numerals folder. Let me make that bigger. Inside, I see that there's a JS folder and a Python folder. One thing I wanted to highlight, because I think several students had an issue with this yesterday, totally understandable, it's happened to me. You want to make sure you're in the right directory when you are trying to run a JavaScript or Python file. So if I bring up my terminal within VS Code, and the shortcut for that is Control tilde. Tilde is that key under the escape key that you probably never use, but Control tilde will bring up my terminal down here. And so currently, if I look at my path, it's November Platoon challenges and Roman numerals. But my file explorer tells me there's 2 nested folders. There's a JS folder and a Python folder. So if I want to run like the Roman numerals spec.js, I can't just run it out of here. So let me just try doing that. So if I do So I'm going to try to run Roman numerals spec. All right, so I get this error that says module not found. And the reason being is because it can't locate this file like automatically. I got to be in the right folder or give it a proper path. So instead, I'm going to cd into my JS folder. And now, now I could run that command. I can hit the up arrow a couple times. I get my input again. And great, so I'm running it. I'm not passing any of my test cases, which ideally I'd want that to change. But yeah, so I'm in my correct directory, ran node, and was able to see that I failed all test cases. That's all right. We're going to be hopefully remedying that soon. So let me open up my spec file. So I double click to preserve it and my numerals file. So looking at test cases, they're pretty simple. So usually we will provide you with some base test cases. We would highly recommend or encourage you guys to add more test cases. Don't just settle for the ones we give you. So yeah, I'm going to actually add a couple of test cases even before I start coding. And this is part of test-driven development. That's something Chad's going to go over tomorrow, I believe. So don't worry if you're not familiar with the process. But basically, I want to set my expectations ahead of time and then make sure I meet them later. So let's go rn to Roman. And actually, I don't know my numerals too well. I guess this is going to be my lazy implementation. So let's just pick a random number. Let's say it's 137, right? So that should equal, let's think about this. Is M what I'm looking for here? Let's go to my README. All right, yeah, M is 1,000. That's what I want C. Again, this is the lazy Roman numerals way, so it's not gonna, let me make that 34. C, XXX, and I. So the lazy Roman numerals way, it doesn't use like the subtracting method for numerals. So I believe this output should be CXXX, I. Let me just add one more just for good measure. Let's keep it a little simpler. Let's make it 49. And that should equal XXX, VII. All right. So assuming that my test cases are correct, I will want to pass all of them once I'm done with Roman numerals here. So let's go to my source file. And let's think about this. So usually the way I approach a problem, most of the time it's like not like a simple, easy solution. I kind of like to pseudocode. And if you're not familiar with pseudocoding, it just means writing some comments in, kind of laying out your game plan without even like worrying about the implementation details ahead of time. So yeah, I'm just going to think about this. I think I'm definitely going to need something that's going to convert numbers, or let's say decimal numbers, to Roman. So again, I'm not even sure how I'm going to go about that, but I know I need something to convert it. Also, I think I'll probably need to, figure out and then I'd probably need to output the Roman numeral results. So, I mean, these aren't highly detailed. There might be more steps to it, but I'm just kind of, creating some sections of my code where I can fill in the logic afterwards. So I guess this is what I'm going to start with. Again, I might need some more steps going forward, but yeah, let's kind of tackle this. So another tactic is to break a larger problem down to something much simpler. So in this case, I'm just going to pretend that I only have two increments. I'm going to say, let's say my increment 10 is, let's say it's 10, and the Roman numeral for that is x. And I'm just going to assign this to a list for now. There might be a better way to do this. And then I'm going to also say my other increment is just a 1 value. And that's 1. And that's I, but actually I'm just going to make this a little simpler for myself so I can see this running, make sure it works. All right, so I'm just going to have my strings be like the literal number. So it's going to be 10 plus and 1 plus as I break down the number I'm trying to convert. So these are my only two increments in my imaginary case. And so let's think about how I break this number down. So I like to use an example. I'm just going to actually ignore my input right now and say num equals, let's keep it simple. Let's say num equals 23. All right, so I'm kind of ignoring my input here. I just want a test case that I can control within my code. All right, so num equals 23. So let's think about how we kind of go breaking this number down. So usually you want to start with your larger increments because they kind of, that's kind of how we form our numbers. So in this case, I'm going to look at this and say, how many times does 10 go into 23? Now it doesn't go into it evenly, but I know that, just doing mental math, that I could use 2 10 increments to get to a value of 20. And then I'll need some number of 1 increments to get to my other digit there. But for now, I'm just going to worry about my first one. So I'm going to write a actually not even a for loop. I'm going to take my number and divide it by my increment 10. All right, so this will actually not give me quite what I want. So if you recall, you're going to have, I guess, a floating point number here, or a number with a bunch of numbers past the decimal point, because 10 does not go evenly into 23. So if I actually print that out, let's check what the value will be. Results, and let's run node. So I'm not going to run my spec case in this case. I'm just going to actually run my main file, and to do that, I'll have to call my function. To run it. And again, the value I pass in doesn't matter, but actually in this case, I'll pass in 23, so I probably shouldn't sign it there. Sorry about that. So I'm passing in 23, and I'm just outputting this division result. So it's definitely not going to be the correct result I want, but I just want to kind of make sure I'm seeing what I want. All right, so I actually got not a number, which is not what I want. Oh, because I have an array here, not a number, obviously. All right, so I actually need to get the first indice from that, which would be my 10. I was dividing by an entire list, which is obviously not going to be a real number. So if I do this now, let's give that a run. All right, I got 2.3. So again, I was just looking for how many times my increment goes into my original number. I don't really care about the 0.3 in this case, because I don't want 0.3 of an increment for my 10. So the way to go about this is you want to round it down to an integer number. The common way to do that is to use something called MathFloor. I don't know if you guys are familiar with this method, but it's just a built-in method for JavaScript. And basically what this will do is round it down to the nearest integer. So in this case, I'm hoping if I run this again, I should get an output of 2, not 2.3. I'm going to clear my screen. Turn this up a little bit. All right, let's run that again. So hit my up arrow a couple times. All right, great, I got 2. So again, as I was talking through this, I'm trying to figure out how many times my increment of 10 goes into my number. And the value is 2, and that's kind of what I expected doing that mental math. So yeah, I think this achieves what I wanted to at this part. All right, so now that I've gotten this increment, I know that 10 goes into 23 at least 2 times, or 2 times. So my next step is to focus on the next digit. So I'm just going to write 23 here, so I can just reference something. So I got the 20 part handled. I need to worry about the 3. So to do that, I need to find the remainder of what I was working with. So let's just create a new variable called, actually, I'm just going to reuse the number. I'm not sure if this is, let's keep it simple. Let remainder equal num. And then if you guys remember your modulus operator, or modulo, I'm going to mod that by my increment. Again, that's a list, so I need the first element. And so this should extract the remaining digit that I need to deal with. So let's console.log my remainder and make sure that's what I want. Yep, so I get the 3 out of the 1's place, which is what I wanted. And basically, I'm going to do the same thing I did above here, but now I want to use my 1's increment. And that should be so let's say let result I don't actually need to math up for it, but just to be consistent, since we're dividing by 1, it's not going to really matter. It might be a little silly example here, but just want to see some consistency between my code. So I have a result 10, which tells me how many times 10 goes into my number, and the result 1, which tells me how many times 1 goes into my remaining number. And then I want to kind of put all those numbers together. So let's do results 10. Sorry about that. All right, so I'm gonna take my string output and repeat that based on results. So this repeat method is just it's a built-in string method. It ideally, if I'm correct, should repeat as in create multiple copies of my string in my increment list. And let's verify that. Always good to check your assumptions. All right, I'm gonna run this again. All right, so I got what I wanted. I got 10 plus, 10 plus, which is, I have 2 increments of 10, so that's kind of what I wanted to see. I'm gonna add that to my final results. So let's create a new variable. Let's Roman equal, I'm just gonna build this string up using repeats. And I'm gonna do the same thing for my ones increments. Do that there, result 1, and print out Roman. And that's not what I wanted. Oh, because I'm using num here, not remainder. Always. All right, let's clear my screen, get some space here. Sorry, I'm having some serious typing issues today. Sorry about that. All right, I think I'm good now. All right, so I got my output, which is kind of what I expected. So I'm seeing 10 plus 10 plus 1 plus 1 plus 1. So based on the way I have this configured, that is what I expected, because my input is 23, and I'm breaking it down into 10s and 1s. All right, so that's kind of my bare bones simple example. I feel like I have a good general process here, but there are definitely some modifications I need to make, and obviously we need to return a Roman numeral, not this plus string item here. So I'm gonna actually convert these to X's and I's, because that's what Roman numerals use, and rerun my code. All right, so I see something that looks like Roman numerals. Again, I don't know if this is gonna work for every case, but I believe that's 23 in Roman numerals. So I'm good with that. Again, we're using a lazy approach, which is detailed in our README, but basically the lazy approach doesn't worry about, the IV when you have 4. So if I change this to 24 down here, I should get X, X, I. Yep, looks good to me. All right, so again, this isn't a complete solution because I'm only using 2 increments. However, there are more in Roman numerals. I think the README details them. We have I, V, X, L, C, D, and M. Those are the only ones we're going to worry about. I'm actually not sure what comes after M. All right, so we're going to have to add a bunch more increments here. So looking at the solution I have right now, I see I have some repeated code here. Like, for example, I'm doing a MathFloor on some value and then dividing it by the increment and then doing that again for the ones place. Now, if I have like 10 different increments, I'm going to have the same general lines of code 10 different times. So that, to me, tells me there might be a better way to structure this. So I think using a for loop might make more sense, but I'm going to have to change my data structure here. So right now, I'm storing individual increments in individual variables. That can work, but it's going to not be easily scalable. So here's where I will use one of my data structures. Again, we're going to go over data structures a little bit more after, but I assume a lot of you are familiar with objects and arrays by now. So I'm actually going to create an array. and call that, let's say, conversion. Okay, so I have this conversion object, and I'm actually gonna make this an array. And I'll talk about why I want it to be an array and not just an object, I guess probably after this coding example. But the reason I'm using an array is because it guarantees order. And I'm gonna want order because I want to use the largest increments first. And if I use an array, I can kind of control the flow of that. So I'm gonna nest an object inside of my array elements. And yeah, let's just start with our increments. So I actually want to use my largest increments first. So I'm going to start with the thousands place, which is m. So my key here is going to be 1,000, and my output is going to be m. And I'm going to create a bunch of these increments. So 500. I keep forgetting what these are. We got d. So the reason I create an object is just to associate the decimal value with the Roman equivalent. I could probably separate these, but it's easy to keep them together. Let's see, I believe. Then I go to 50. That's L. I know that from Super Bowl notations. What's next? Tens. And a couple more. So we have 5, which is V. And let me just space this out a little better. And finally, we have our ones place. Right, that's I. All right, so I have my data structure set up here. So now I have a bunch of entries that kind of map out decimal values to the Roman equivalent. And I'm going in descending order. And I'm controlling its order. So I can kind of use that to my advantage. And so I'm going to get rid of my increments here. And I'm going to be relying on my conversion array to get my increments. So now, as I kind of mentioned before, I want to be using a for loop here. And the reason being is because I'm doing the same thing over and over generally with a few changes. I'm using different increments each time. But otherwise, I'm MathFlooring, and I'm going to be dividing the same number. I guess it's not quite clear here. So let's write a for loop. So if you guys remember the syntax for that, it's going to be for. You need an increment value. So I'm going to call it I. It's going to be starting at 0. And my I is going to go through my conversion array. So conversion and length is how I get the length of that. And then I'm going to increment each time, go up by 1. So this is the same thing as plus equals 1. Plus plus is just a shorthand. Hopefully you guys are familiar with that, but it's not obvious. All right, so that's what my for loop is doing. It's going through this array. It's going to each time it's going to hit one of these object in my array. All right, so let's look at what I was doing before. I'm getting a result. So let's say results. I'm doing math.floor, and then I'm taking some number and dividing by an increment. So my increment is a decimal value, so that's going to be my key in this case. So conversion. Actually, sorry. I should probably take advantage of a better way to do this. I'm going to change my for loop and actually use this notation. So this will get me the key, which is, I guess that's wrong too. All right, backtrack. All right, so my conversion array has objects in it. So let me just grab that. So let's say inc equals conversion and I. So I just kind of want to see what this data looks like. So I'm going to console it, plug, and inc is the value right there. All right, let's go with this for now. Make sure get this stuff out of the way. All right, so as you can see, my entire array got printed out from this for loop. So each time I'm going through it, I have these objects that printed out. So that is what I wanted to see. But now I need to use a decimal value in some case. And however, this is a string, so we'll likely need to convert it. So the method for that is parse int. So if I have my int, I'm going to need key format. All right, so I'm not sure if this will work, actually. Pardon my JavaScript rustiness. And then let's see if this works. But that does not work. All right, so I'm not getting what I want, but I need to figure out how to extract this key. All right, so one way to do this, I guess, is to use keys. So I need to extract the key out of my object here. So I'm going to use the keys method from object, use that on my ink object that I declared earlier. So we need to eclipse here. Object, so this will extract all the keys. I only have one of them, so I kind of know that just looking at my data structure, so I can just grab the first one. All right, so ideally what this should be doing, this is kind of complicated, so I might want to break it down. Let decimal string equal this one. So this is extracting this part. However, this part is actually a string when I look at the printout. So I need to convert it to a numeric value that I want to use. Parse int will convert that string to actual numeric value, ideally. So if I run this. All right, great. So now I can see this as a decimal value, and I know that because there's no quotes around it. If I didn't do parse int, I'd see a quoted 1,000 here and a quoted 500 here. All right, so that's closer to what I want. And so now I have my decimal value. Let me get rid of some of these consoles. Console.logs, don't need this, don't need that. All right, so let's go here. And just for clarity, I'm going to create a bunch of variables. Usually you don't need, keep all these variables, but I kind of want to make it clear what each step is doing. So in this case, I want to convert decimal string to actual numeric value. All right, so I have my numeric value, and then kind of deleted my code before, but let's call let results equal math.floor. Num is our working number, and decimal is the increment in that case. All right, so this is going to tell me how many times this increment goes into my number, and it's going to round it down because I want an integer value. But I also need a remainder. So in this case, I'm just going to use my original number and assign back to it, which is totally valid. I'm going to mod that by my increment again, which is dec. All right, so again, just to make sure I'm on the right track, I'm going to use my console logs. So I want to print out results and print out the remainder, which is num in this case. So let's see what my for loop's doing and if it's doing stuff correctly or not. All right, let's clear my console. Run that again. All right, so let's take a look at this. My input is still 24. If I scroll all the way down, I'm passing in 24. And so it's gonna go through all these increments, and let's see what's happening. So the first time I'm in this loop, my first increment is 1,000. So Looking at 24, we know that 1,000 does not need to go into 24, so that's why I have a 0 here, and 24 is my remainder. So I've not, dealt with any of the actual digits in my number. Next, we have 500, again, get 0, then we have 100, then we have 50. But then when we get to our tens place, I can see that 10 goes into 24 2 times, and my remainder from that is 4. Then we go to our fives place, and 5 does not go into 4 fully, so I have a 0 there. And then I go to my 1 digit, which is goes into that 4 times. So I feel like I'm on the right track here, so I'm just going to continue, get rid of these console logs. And all right, so now I think my final task is to actually convert to Roman numerals here. So I have my key here, but I need my values here. So the way to do that, if you want to extract values, let's say Roman num is objects. Actually, since I have my key, I should do that. So I think, so here I'm using the key that I extracted earlier and using that to extract my value from my inc object. So let me make that more clear. That's an object. Always good to have properly named variables. All right, I think I caught them all. All right, so ideally this should extract the numeral part of it. And as we did before, I want to assign that to create a final variable. And it's going to call it Roman. That's going to be an empty string to start. Next up, I'm going to want to add to that. So I'm actually going to do a plus equals, which is concatenating to that string. And I'm going to take my Roman num, use repeat. Again, repeat just replicates the string as many times as I want to. In that case, I'm going to do it result times. Does that make sense? Maybe I should name these better, but basic result is, again, how many times my increment goes into the number at hand. So I'm going to repeat my Roman numeral that many times. I guess I could put this later. And again, I think I'm failing at writing comments here, so I should add some comments. So get remainder, determine how many increments goes into, and all right, so comments are always good, good practice. Don't want to be a bad example there. All right, so I have some comments here, so I kind of know what each piece of my code is doing. Repeats and appending. All right, so one more check I want to throw in here. I just want to see with each iteration what's going on here. So I'm going to log that. So it's going to log out my Roman value, which is what I'm aggregating with this for loop. And then ideally, I want to return Roman at the very end. So let's get rid of some white space. My final thing I'm going to do is return Roman. All right, so let's give this a try. Hopefully I have no errors. All right. Sorry, let me bring this up a little bit. All right, so this looks like the answer I wanted. I have XX, I, which is what I had before. I have some empty space, and again, that empty space is from the increments that didn't go into my number, which were like 1,000, 500, like those are larger numbers. So yeah, this is looking pretty good to me. This is where I would go to using my test case now. I feel like I have a good working solution. I did a simple example myself, but now I have all these test cases I can run. So let's see if I'm doing this correctly or if I made a mistake. To do that, I'm going to run the spec file. So I'm already using my Roman numerals. I have my 2 Roman function calls, so that's all set up for me. So let's give this a run. So I'm going to run node. I should skip some space here. I'm going to get rid of some console.logs. All right, I did that. All right, let's run node. Roman numeral spec. I'm having a pretty terrible typing day here. All right, so looks like I failed the test case, which is not good, but I passed 4 out of 5, which is pretty good. Okay, so in this case, this is not the lazy method. I didn't realize that. So I'm going to add III there. And all right, so I'm passing all my test cases. Now, again, this is the lazy approach, which, again, to clarify, that's where we don't use IV for like 4, for example. We're just going to use like 4 I's. I think the actual rule, I might be incorrect, so don't quote me on this. I think the way Roman numerals are structured, if you have 4 repeating numerals, that's when you're going to switch over to the subtraction method for the actual notation for it. So, all right, cool. So this is my lazy test cases. Let's say lazy Roman numerals. All right, so I'm pretty confident on my solution. I obviously could add more test cases to make this more thorough, but in interest of time, I'm gonna assume that my solution is correct and kind of go to the, let's call it real Roman or modern, I believe the terminology we use. All right, so I'm gonna actually copy these test cases. However, there's gonna be some changes. As we saw before, we actually want IV printed for this. I think some of these had to change, like this will have to be IV. I'm actually not sure if these are correct, but I believe 49 will have to be, let's see, XL. So it's 40. I believe this is 49. I guess we should double check. So what is 49 in Roman? Yeah, XLIX. So close, but all right. So I have some test cases for the modern. Okay, so some of the values are going to be the same. Others have the subtraction method. So all right, let's go to modern. So thinking about this, I have a pretty good approach here. I'm using these values, but now we have an added twist. We have more values that need to be represented. And there's actually several ways to go about this. So there's a, I guess, harder way, which is kind of the method I described before. Like the rule is if you have 4 identical numerals together, then you have to switch over to the subtraction. And the rules there are like use the next largest increment and subtract from that. Again, I'm not stating this correctly, but to avert that, I'm just going to say there's an easy way to do it. And that's just by figuring out which, how many buckets or increments that you actually have, and then using those to adapt your solution. So I'm actually just going to copy this and create a modern variant of this. Actually, let's step up. All right, and I'm going to say this is Roman modern. All right, so we have the same values as before, but we have some additional increments that we need to worry about. So I'm just going to work from bottom up because I know the bottom values. We know 4 is IV. So I can just add that in there. Let's see. After that, we have 9 as a special case, right? Because 9 is right before 10, and that is IX. So I'm just creating this bucket, these buckets, because I know that these increments exist and they have a specific value associated with them. Again, there's the other method, which I think is more difficult, is to kind of generate these notations or these numerals yourself. Like you do some fancy algorithm where you know that right before you get to 10, you need to subtract 1 to get to 9 because you have 4 ones in a row. But again, I'm not going to go down that line because I think I would fail at it miserably, and there's a much simpler way to do it. I think 40 is the next bucket here, and that is, again, we subtract 10 from L. We have 90. And here we need to subtract 10 from 100. And we have a couple more. I think 400 exists. That will be 100 minus D. And the last one I think we need is 900. So if you actually enumerate all the possible values, it's actually not that many. So I don't know if some of you guys might have gotten stuck and said, okay, there's too many possibilities. Like there's no way I could create a data structure for this. You know, that's totally reasonable to assume that offhand. But if you actually go through the motions and realize, okay, there aren't actually that many increments I need to worry about, it kind of makes it more obvious that you could just have your own data structure rather than trying to dynamically figure out Roman numerals. All right, so I think I have these correct. Again, I'm not an expert in Roman numerals, so I could have screwed something up here. But all right, I have my new increments. And the great thing about this is I can run the same algorithm because this is going to be doing the same exact thing. I'm going to use my largest increments first. So if I can use 1,000, I'll use as many thousands as I can. Then I actually drop down to 900, which isn't a huge drop off, but if I have like a number like 1905, I'm going to use 1,000 increment and then 1,900 increment. So this algorithm, I believe, should still work. The only difference is instead of using conversion decimal to Roman, I need to use my modern variant. So this is where I could create a duplicate function and just use this in that function, but that's going to be a lot of duplicate code. So instead of doing that, I'm actually going to make this a variable. So let's add a new parameter here, say modern equals false. And this is saying by default, I'm not going to be using the modern values, but if I want to, I'm just going to pass in a new value here. And then I'm going to create a variable called conversion data. And then I'm going to use a ternary. So again, hopefully you guys are familiar with all the notations and structures I'm using. If not, definitely we'll go over that in discussion or at a later point. But I'm going to use a ternary operator here, and that's going to be modern. And format that a little better, conversion to Roman. Or if modern is true, I want to use modern. If not, then I want to use my original lazy implementation. So I have two data structures here. Both are arrays. One has more increments in it. Otherwise, they're essentially the same. And then my modern parameter, which is passed in the default value is false, is going to determine which data structure I'm using. So if I now adapt that here, I think just a couple of places I'm using it. All right, great. So now this is kind of more dynamic. I can kind of control which data structure I'm using, and my algorithm, as far as I understand it, will not have to change. And to verify that, I'm going to run my test spec again. Just to make sure I have my test cases kind of organized. All right. Save that. All right. So fingers crossed, I'm going to run my test spec again, and hopefully they pass my modern case. So again, my modern cases have a few changes. They use the IV notation. There's an IX in here. Again, let's add one more test case just to be a little bit more robust. So let's pick a random number. Let's say 792 in Roman numerals. I have no idea what this actual value is, but Google tells me it's this. I'm going to trust Google. Hopefully it's not lying to me. So let's add in one more test case, console.log rn to Roman. What was my number? 792, right? Yeah. And that ideally should equal what I got from Google. But one more change I need to make, if you guys didn't catch that, I added a parameter here. I will caveat this by saying normally you shouldn't be changing the function signature for like a function that either a coding challenge gives you, because the test cases are going to be running off that that function. If you change the signature, it could cause the test case to break. So again, I'm hopefully not being a terrible example here, but just usually don't go about changing the function signature. So if you did want to tackle this, you could create a new function, for example. There are other ways to alleviate this other than adding a parameter yourself. But again, just to make this a little simpler, I'm just going to use the same method. So in this case, I want to pass in true, which means I want to use the modern conversion data instead of the lazy implementation. So add that to all of mine. All right, I think I should be good to go, except obviously I have extra parentheses here. All right, I'm going to save that. I'm going to run my test spec, cross my fingers, and looks pretty good. I have an output here. I'm not sure where that's coming from. Oh, okay. Typing is hard some days. Let me just clear that. All right. Looks like I'm passing all my test cases for both lazy and modern. So at this point, I'm pretty confident I have a good working solution. Again, I might add a few more test cases, make sure I hit all like the corner cases, like try like 49, maybe 499, like 749, all those cases where you have to subtract the Roman numeral. But otherwise, I feel like I have a good working solution here. So going off of that, I'm going to commit my changes to my local repository and then upload it to GitHub. and then submit a pull request. So I'm going to go through those motions again. Hopefully by now you guys are bored with this process and it's familiar. If it's not, again, this is kind of what I just want to go over it so that everyone's familiar with how to upload to GitHub and then also submit a pull request. So my first step is I'm going to do git add dot. And if I want to check what's changed, I could do git status. So it looks like I modified two files, my spec file and my numerals JS file. Again, we totally encourage you guys to add test cases. We're not using these test cases on our end to like validate your solution. This is for your testing purposes. So definitely add more test cases, more corner cases, anything that's more robust, like more thorough, I guess will verify your solution better. Okay, so we have git status. These are the files I modified. Sure, I'm good with committing those. I'm going to do git commit, add a message. I'm going to say completed lazy and modern Roman numerals. So if I were a better, I guess, Git user, I might have done this before. When I completed my lazy solution, I might have added that and committed that to my local repository, so I have that saved, and then moved on to working on the modern solution. So that kind of piecemealing that in Git so that I have a history. So for example, if I did my modern solution and somehow broke my code in a severe way, I could actually roll back and go to my working solution when I had the lazy implementation working. But in this case, I did both of them and putting them together. Of course, typo. All right, hit enter. Looks like that committed fine. I'm going to clear my terminal. Last step I need to do is push, use the git push command, which uploads it to GitHub. So I'm going to do git push origin. It's going to do some work. All right, I think that worked successfully. To verify, I'm just going to go to my GitHub, go to my repository, which was Roman numerals. All right, so if I look here, just a quick check, I see a timestamp 34 seconds ago. These files were updated, which makes sense because I just committed these. If you look at the other timestamps for Python, it's 2 years ago, the README 2 years ago. So this is when probably this project was created. Whoever created them committed them. So that's what those timestamps are for. So that makes sense. I didn't modify those files, so I don't expect a recent timestamp from those. So everything looks good. If I wanted to check what values I have, I could go into the file itself and then click on the commit. And, okay, so this kind of shows me a detailed version of what changed. So the red just means I removed something or modified it. In this case, I modified it by adding a parameter. I added all this code. It looks reasonable. I modified some test cases, added some test cases. So yeah, this looks good to me. I'm ready to commit this. So in this case, to do that, we go to the pull request tab up here. Hit pull request. I'm going to hit new pull request. And then again, review your code. So yeah, this looks like what I committed, what I want to commit. I'm going to create pull request and modify this. I'm going to say Roman numerals solution and then add my name so the instructors know that's my solution. If I want to leave a comment, I can. Like if I said, hey, this was a hard challenge, I can. Comments are optional. I don't think we really investigate the comments too much, but feel free to leave a comment. We'd love to see those. I'm going to hit create pull request. And it's checking. Got a check mark here, so it looks like things are good. All right, so I think I'm good here. If I go to the pull request tab in November Platoon, which where I got transferred to, I should see my solution. And there it is. So Roman numerals solution encore. I see some of you guys have submitted, which is great to see. But great. All right, so that's the entire process of getting a challenge, forking it, pulling it down to your machine, working out the solution, which obviously is the hardest part, and then adding it to your repository, committing it, and then pushing it up to your GitHub, and then submitting a pull request. It's a mouthful to say. It's a lot of steps, but again, this should become second nature the more and more you guys do it. All right, great. So that was Roman numerals. Hope you guys enjoyed that challenge. And again, hopefully you guys were able to solve it. If not, no worries. That's what it's for practice. It's not for testing purposes at this point. With that said, I think we should take a break. We're going at it strong for like 50 minutes. So I'm going to pause the recording. Let's resume at 10 a.m. Central Time. So stretch your legs, stretch your eyes, whatever you need to stretch, go for it. And we'll reconvene in 6 minutes. All right.